Okay, our objective today is to start chapter 7. We are going to talk about graphing linear systems and solving systems by substitution. The entire chapter 7 is based on systems of equations. So we're solving two equations, and we're going to learn all the different methods and ways that you can solve two equations. Some of this we've done, so some of this should be extremely easy today. And the graphing portion I'm going to show you on the calculator since I haven't shown you how to do that yet. So I told you to skip down to warm-up number 2, just as a review for linear combinations, and then I'll explain how this relates to the chapter. So Dirk, can you tell us, was negative 3, 1 a solution of the first equation?
Yeah.
Good. Amy, was negative 3, 1 a solution of the second equation? Should be yes. Negative 3 plus 5 times 1 equals 2. Negative 3 plus 5 is 2. You know what I mean? Okay. All right, Melissa, and the second one was 5, 2 a solution of the first equation? Good, yes. And Jackie, was 5, 2 a solution of the second equation? Good job. This one was no. The reason this one was no is 10 plus 16 does not equal 11. So that one was no. These are all reviews and examples of linear combinations. So why are we doing this again? We're doing this again because these ordered pairs are a solution to these equations in the first one. When we're solving systems of equations, they can have one solution, no solution, or many solutions. So just a reminder, this is proving or telling us whether this ordered pair is a solution or not of these equations. Okay? All right, so let's do this graph one by hand, and then I'm going to show you the second one on the calculator. So letter A, do you guys remember these? Graphing, finding the intersection point. Do you remember these at all? Okay, we did do these. Okay, so let's graph the first one. I'm going to graph the first one in red. So as a review, y equals 2x plus 2. Rena, where do we start this one? Good. So everyone go up 2, start at 0, 2. And Heather, our slope is 2, so what do we do next? Good. Rise 2, run 1. Rise 2, run 1. To get the opposite point, down 2 to the left 1, down 2 to the left 1. And I have a lot of points on there. The reason is we need to find where these equations intersect. So I'd rather you have more than less points. John, you with us? Okay. Connect them as neatly as you can. If I probably should have given you all rollers, but just as neatly as you can, connect them. Okay, let's graph the second one. Sam, where should we start the second one? Careful. Good, up 6. So 1, 2, 3, 4, 5, 6. So start at 0, 6. Katrum, how do we get to the next point? Good job. 1, 2, 3, 4 over 1. To get the opposite point, down 4 to the left 1, down 4 to the left 1. I'm going to do one more. Down 4 to the left 1. Let's connect our points. Oh, that wasn't so straight. As neatly as you can. So those two equations intersect at one point. What point do they cross at? In other words, what is the intersection point? Really, really, really easy. It's right here. What ordered pair is that? You guys learned this a couple years ago. I know you're tired. Helene, what point is that? Yep, negative 2, negative 2. So the equations intersect at negative 2, negative 2, which means that ordered pair is a solution to both of those equations. Easy? Okay, so here's what you're really going to do on your homework. So I want everyone to open up your calculator, clear the home screen, and go to the y equals screen. I wanted to do one by hand just as a review. Go ahead, open up your calculator, clear the home screen, go to the y equals screen, and clear what's there. Let me, I need to fix one thing on mine. Okay. All right, once you're there, we're going to type both of these in, and then I'll show you how easy this is. So 2x plus 2 is the first one. Second one is 4x plus 6. So 2x plus 2, and then 4x plus 6. And don't forget, this is the x. Okay, this is something, I'm going to show you in a second, but this is something I want you to remember for next year, for Algebra 2, for all your future math classes. This is an awesome way to check to make sure that your systems of equations is solved correctly. So hit graph. It will look just like our drawing, or our graph, I should say. So there's the graph on the calculator, same thing that we did by hand. Does anyone know how to find the intersection point on a calculator before I tell you? I think, did Mr. Roth teach you that last year? Anyone remember? Okay, maybe not. Okay, I want everyone to go to second trace. Second trace. Jackie? Okay, give me a couple minutes here. So go to second trace. Does everyone see this screen? Oh, Maggie, I might have to help you with yours. I'll help you once we're done with the lesson. If your calculator for some reason does not have this, or if you need batteries, let me finish up the lesson and then I'll get it for you. So just watch. Okay, press number 5 or scroll down to number 5. Hit enter 3 times. 1, 2, 3. Does the calculator give you the same answer that we got? Yeah. Do you see much easier? Well, if your calculator works, much easier. Good news on the homework tonight, you do not have to graph by hand. You may use your calculator. If you don't have your calculator, then you have to do it by hand. Alan, did yours work? Okay. Is anyone that didn't tell me, are you having issues with the calculator at all? Dirk, it just didn't work? Okay. Okay. Haley, did it say error? Hit zoom. Let me do zoom. There you go. Dirk, let me see yours real quick. Okay, well, you try it again. Maggie, I'll have to help you after we're done here. Anyone else? Garrett, is your calculator in your locker? Okay, okay. All right, let's go to the second one. Haley, we're on example letter B now on page 2 of the yellow packet. Okay, let's go to example 2, letter B, I should say. Instead of doing this graphing by hand, let's go straight to the calculator. So go back to y equals on your calculator, clear what's there. And again, if your calculator works, bear with me. If not, just watch for now. It's pretty easy to get the hang of it. Okay, so let's type in letter B. We have x minus 2. And then the second equation is negative x. Okay, I want you to hit graph. And here can remind us, what do we hit first now to find the intersection point? Second what? Good, second trace. And then what number do we go to, Zach? Good, go to 5. And then hit enter 3 times. 1, 2, 3. I think some of your calculators maybe 4 times. Does anyone have to hit enter 4 times? No? All right. So the answer here is 1, negative 1, which means that is a linear combination to both of these. That is the solution of both of the equations. Questions on that one? Okay, at the bottom of your paper, underneath where it says, let's check these on your graphs, I want you to write down the steps. So put step 1, you need to type them into the y equals form. So I want you to write down underneath where it says, let's check these on the calculator. Step 1, I'm just going to put y equals, which means type the equations in on the calculator, just so you don't forget. Step 2, hit graph. And then step 3, you're going to hit second trace, which really means calculate. Second trace, number 5, and then enter, enter, enter. So I'll say that again. Step 1, type the equations in. They both need to be in the y equals part of your calculator. You then hit graph, and then second trace, which means calculate. Number 5, enter, enter, enter. So just in case you forget, those steps will be useful. Okay, I want you to try letter C on your own, and then I want to show you the next part of today's lesson. So try letter C on your own. I'm going to walk around just to make sure everyone's okay. For letter C, be careful with the fraction. Just like we did in chapter 3 and 6, I would put the fraction in parentheses. So like I did, and then I want you to practice that on your own. Oh, yours is so dark. I wonder why yours does not have calculate. Yeah, I know. Just thinks that doesn't have it. Okay, I'll have to look at yours later. Okay, after you have that on there, hit graph, and then second trace. Number 5, enter, enter, enter. It's completely dead, right? Oh, it says your batteries are low. Okay, see if it works for a little bit. All right, who can tell us what you got? What's the intersection point, Mamta? Awesome. 2, 3 is the intersection point. Did anyone not get that? No, so really easy, right? Okay, let's flip over your notes. I want to show you now, we're going to do a little review of substitution. So we're going to start off with a proof. So notes of 7-2, I want you to take a look at example letter A. But instead of doing it in the notes like it is, we're going to do it as a proof. So if you don't have loose leaf, I want you to leave your note packet opened, but flip to the back of your homework packet. If you don't have loose leaf, use the back of the orange paper of your homework packet. Okay, so if you don't have loose leaf for a notebook, use the back of your orange homework packet. As a review, we're going to do letter A as a proof, and then I'll show you how to do the other ones using algebra. I'm almost done with you. So while you guys are getting organized, substitution is a second way to solve for a system of equations. So I want you to think back to graphing for a minute. When would you use graphing as a way to solve systems? When the equations are in what form? When would you use graphing to solve for systems? When the equations are in what form? Y equals. So I want you to remember, if the equations are in y equals form, it's much easier to use graphing. For substitution, if one of them is maybe in x equals form or one of them is in y equals form, then use substitution. Substitution is another method to solving systems. Okay, on your paper, I want you to write down, this is what we're given, this is what we need to prove. So that's what we're given, that's what we need to prove. And again, this is just letter A on the notes, but we're going to do one of these as a proof, as a review. Okay, what is always step 1? You guys should be able to tell me this. What's always step 1? Zach. Good, the given. So we have y equals 3x plus 4 and y equals 5x minus 2. Step 1 is always your given. So write down what they gave you. The justification is given. Okay, what is step 2? What's step 2? We haven't done these in a while, I know. Zach, go for it. Awesome, transitive. So I'm going to write down transitive property. Transitive property is when they are both set equal to y or x. So they're both set equal to the same thing. You then set the equations equal to each other, and it's called transitive property. Is this coming back to you guys? Okay, now what? What would step 3 be? Maggie, what would we do for step 3? Good job. Subtract 5x on both sides, so I'm going to write it under here. Since you're subtracting 5x from both sides, this would be subtraction PO. I'm going to abbreviate. Subtraction property of equality. It's an equation. You're doing it on both sides. So we would have negative 2x plus 4 equals negative 2. Okay, Garrett, next step. Where do we want to move now? Good. So we now need to move the 4 to the other side. You're going to subtract it. So we have negative 2x equals negative 6. This would also be a subtraction property of equality. You are subtracting it from both sides. Haley L., next step would be, good, divide both sides by negative 2. So we'd have x equals 3. This is division PO. Remember, you're doing it on both sides, and it's an equation. All right, so we proved that x is 3. How do we prove y is 13? John? Good job. Put x is 3 back into an equation. It does not matter what equation you use. I'm going to pick the first one just because. So step 6 is going to be y equals 3 times 3 plus 4. That is substitution property. So I'm just going to abbreviate substitution property. Now you can either do this next step in one step or in two steps. I'm going to do it in one step. So step 7 is going to be combine like terms. 3 times 3 is 9 plus 4 is 13. And I'm just going to call that combine like terms. Some of you I know like to do the multiplication step first, and then you would write down multiplication property, and then you would write down add, which would be your 9 plus 4. So 2 steps is fine. I'm just going to keep it like 1. That's it. You guys remember that? Okay. All right, let's now do them without a proof. So let's take a look at letter C. Oops. So without a proof, I'm going to make this, I'm going to move this here. All right, would this be a transitive or substitution problem? What kind of problem would that be, Rena? Good. Why is it substitution and not transitive? Okay, that's okay. Anyone help him? Why is this a substitution problem and not transitive? Amanda? Awesome. Only one of them is isolated for a variable. In other words, one of them is in y equals form. If one of the equations is in y equals form, this expression is going to be substituted into that variable in the other equation. That's why this is a substitution problem. If it's transitive, they're both isolated for either y equals or x equals. So let's do this. We have x plus 2, and then parentheses, 3x plus 2 equals 11. Do you guys remember that? You were really good at these when we did them. It's just been a while. So without the proof, all we're doing is solving for x. So the first thing we need to do is distribute. So we have x plus 6x plus 4 equals 11. Sam, what's the next step? Good. Combine like terms. So 7x plus 4 equals 11. Alan, what would be the next step? Good job. Subtract 4. So we have 7x equals 7. And then to solve for x, divide both sides by 7, we would get x is 1. So we know so far that our ordered pair is 1 comma something. Jackie, how do we find y? Awesome. So I'm going to plug 1 back in for x in the first equation. So we have y equals 3 times 1 plus 2. Maggie, what's y going to be? Good job. So y is 5, which means you always need to write your answer as an ordered pair. The answer to that ordered pair would be 1 comma 5. That's it. Thumbs up, thumbs down, thumbs down. Is that easy? Hard? I don't know. You guys are so tired, I know. Okay, I want you to try one on your own, then we're done. Letter D, go ahead and try that one on your own. You will get a nice answer. So letter D, try that on your own. You'll get a nice answer as long as this goes well. We will start homework. Again, you'll get a nice answer on this one. You lost the y. It should have been negative 2y. That 2 needs to have a y next to it. Is this your answer? Is that a 5 or a 3? This negative divided by negative is a positive. That's why. It's okay. Did you get it? No. Okay. Negative 2y plus 1. What the heck? Plus 5 minus 14y plus 5. Oh, you're subtracting a 5, not a 3. That's why. Awesome. Good job. Awesome. Good job. Did you get it? You're still working. Okay, you did something wrong. All of this, Garrett, goes in for x. So it should be 5 times the x is gone. When you plug it in, the x goes away. Good job. Oh, is this your answer? You had, oh, no, you're good. Sorry. This should be a negative 3. Sam, did you find x? You have to have x and y. Your answer needs to be as an ordered pair. Awesome. All right. The answer here should be negative 3, 2. Let me just go over the first step. The very first thing you need to do is take negative 2y plus 1, plug that in for x. This is a substitution problem. So take negative 2y plus 1, plug that in for x. So you should have 5, negative 2y plus 1, minus 4y equals negative 23. From there, solve for y. You get y is positive 2. Once you get that, plug that back into one of the original equations, and you get x is negative 3. I can finish going through that. Does anyone need me to? Any questions? All right. Okay, let's open up your homework packet to page 1. So I want to start there. Page 1, which is a graphing one. If you have your calculator, you are going to use your calculator and not graph by hand. So page 1 looks like this in your homework packet. There's a front and a back. I want you to do 1 through 10, but it should not take you long because you're using your calculator. If you don't have a calculator or something's wrong with it, then you have to do it by hand and write down the ordered pair. I believe they're all nice intersection points. Yeah, they're all nice answers. So you should be fine with that. Melissa? Yes, all you need to do if you're using your calculator is write down the ordered pair. Yeah, they're all nice answers. If you don't have a calculator, do them by hand and then write down the ordered pair. Those of you that are having errors, I'll be over in a second to help you. And then page 5, so flip to page 5. It's the ghost puzzle. I can't decide here. Okay, I'd like you to do numbers 1 through 5, I think is all I want you to do. Yeah, just do 1 through 5. So that's not bad. All your answers need to be written as ordered pairs. Remember, if both equations are in y equals form, use graphing. If you're using substitution, one of them should be in standard form, one of them should be isolated for either x or y. Okay? So that's all. I'll be around to help you if you guys need it, and calculator people that need help, I'm coming.